Okay, stat students. So I went ahead and I typed up some of the missing words that are in the notes. So go ahead and just take a minute and pause the video, fill in the stuff, and then let's go ahead and talk about it. So pause, write, and then play and have me talk about it. Okay, so we have two types of statistical studies that we're really going to look at. Our first type is an observational study. We observe people, or we observe animals, we observe something, and we measure the variables of interest, but we don't influence the response. So we're interviewing people and getting that information, or we're watching things happen, but we're not actually taking part, we're not trying to change what's happening. It's always about watching or surveying, and that's an observational study. Now, observational studies are they're a lot easier, but the results really can't establish any sort of cause and effect. And so that's where we kind of hit the limitation with observational studies. But with experiments, we're deliberately imposing some sort of treatment. And in section 4.2, we really delve in deep into how to run an experiment properly so your results are actually reliable results and something that you can actually do something with. So we're imposing a treatment on individuals and we're measuring responses, and that allows us to have this cause and effect treatment. And that's really our big idea is if we can, we want to try and establish some cause and effect. And that only happens from our experiments. There is a special caveat if it is unethical to experiment on someone, and the example I always use is drug use on babies. So if you're not purposely going to give cocaine to moms while they're pregnant and see how it affects the pregnancy and the baby, because that's unethical. And so what we would do is a lot of different types of studies, and as long as the results are consistent among lots and lots of different types of observational studies, we might be able to then take a step and establish cause and effect. But that's not something that we're going to worry about. We do need to know that whenever you're planning an experiment, it needs to be ethical. It needs to meet the basic ethical guidelines. You have to be able to live with yourself after performing that kind of experiment. So it's important that we follow those type of guidelines. The goal, like I said before, many statistical studies is to show that changes in one variable causes changes in another variable. And we can only do that through experiments. If we are using observational studies, then we say that there's association. There's a relationship there, but we haven't done enough to really establish that there's a cause and effect. And so a lot more studies would have to be done to be able to reach that without an experimentation. So the very first thing you ever want to do in a statistical study is identify your target population. Who do you want to know more about? Who are these people? Or who are these animals? Or what do you want to learn more about? And the population of statistical study is always the entire group of individuals that you want information on. Do you want to know about all high school males, or just high school males in the United States, or high school males that play U.S. sport, or in the U.S. that play sports, or high school males in Alaska, or high school males in Palmer? So you have to be specific about that because that's going to affect your study. So you always have to be really specific about who, and that's going to affect everything you do from there on out. So once you identified your population, and if you're going to involve the entire population in an observational study, and usually the only time you can use the entire population is in an observational study, then that's called a census. So using everybody is a census. Now that can be really expensive, especially if you have a big population to work with. And you hear census all the time. The United States has a census every 10, 20 years or something, because it's expensive to get people out and try and interview every single person. We try and not leave anyone out. Because it's a census, we want to know about everyone in the United States, all sorts of data about them. But when it's too difficult, too expensive, too time consuming, we take a sample. And this is our big idea because most statistical studies are based on samples. And so our sample has to be from our population. So I can't just look at high school males in Palmer and assume that represents high school males in the entire United States. I have to sample from high school males in the entire United States. So when you're specific about your population, that controls how you start picking your sample. And then you're going to use the information from your sample to draw conclusions about the entire population. Now, you can use the data from your sample to what we call generalize about your population, but only if you sample correctly. And so that's in 4.1 what we're going to sit here and talk about. We're going to talk about all the different ways to sample and which ones are good and which ones are not good. And please remember, there are specific procedures for gathering and analyzing data. And so looking at our sample, going through and doing things a specific way, so that way we don't end up with bogus results. And you'll find over and over when you hear in the news about, oh, this survey and all that a lot of them are bogus. And they're not reliable at all. And we're going to talk about that and analyze that. Okay, so these are our different types of samples. Please feel free to pause so you can fill this in. Okay, let's talk about our sampling methods. So different ways to choose a sample. The first one is called a voluntary response sample, and it's exactly how it sounds. The people volunteer to respond to your survey or volunteer themselves to just be a part of it. So they're always choosing themselves. And that could be a write-in poll, so they choose to write in, they choose to answer the phone, they choose to do a survey online, but they're always picking themselves. And one of the things about this is the people who feel strongly. One way or the other will respond. You never really get a big voice from those mediocre people, the people who, or it's just really not worth my time, or I've got a lot going on. You don't hear from them. So you only get your extremes responding to this. Okay, our next one is a convenient sample. Choosing individuals who are convenient to get results from. Only talking to your friends. So if you want to look at all students at Colony High School and you want to identify how they feel about something, but you only talk to your friends, you're eliminating a lot of other people and a lot of other opinions because friends tend to think alike. And so you're limiting your information and it becomes unreliable. Also, if you're looking at high school males and you only look at high school males at your school because it's convenient, then you can only limit your results to people from the school. If you really want to look at high schoolers all over the United States, then you have to sample from high schoolers all over the United States. So just because it's not convenient, then it's not really going to do what you want it to. So you have to be specific about that population, and that in turn tells you how you sample. The next one is systematic sampling. It consists of randomly choosing a starting value, like you randomly pick a number out of a hat and the number is 4. So you start at the 4th person and then you randomly choose an interval. So I randomly choose a number out of the hat and it's 5. So then I interview or I select every 5th person after that. So I select person number 4 and then person number 9 and then person number 14 and then person number 19 and so on and so forth. Systematically going through and doing that. And as long as you are truly randomly picking a starting value, randomly picking an interval, it's really not a bad way to go. But there's some issues with that, and we'll talk about them a little bit. And so the next one, which is really the one that we look at the most, is the simple random sample, also known as SRS. And most of the time, we'll refer to this as an SRS from here on out. It consists of n individuals. N is the number of people. So n equals number in our sample. And the idea behind a simple random sample is that the people are chosen in such a way that every individual has an equal chance to be in the sample. And not just every individual, but every type of sample, every group, every possible sampling has an even chance of being picked. And so we do this several methods. We've got a hat method where we can put all names in a hat and we choose names. Or we can put numbers in a hat and assign each person a number, randomly choose numbers. Or we can use the random number method. With the random number method, we could use a calculator and have a calculator randomly assign or randomly pick numbers for us, and those are the people that are going to be in our sample. We can have a computer randomly pick people to be in our sample. What we tend to use the most is a random number table, and you have an example of one in your notes, and I'll also print one off for you guys, so that way as we're working on stuff we can practice with them. With a random number table, every person or every individual in your sample, so it could be animals or whatever, is going to be assigned a number. And every number has to have the same number of digits. So if you have 10 or less people, you can use one digit. And so you can use the digits 0 to 9 because those are 10 digits. If you have 11 to 100 people, then you're going to use two digits. So 00 to 99. And then so on and so forth. So as you need to creep up, then you start moving into how many digits you have. And so when you have the 00, then you'd have the next person would be 01, 02. And so that just makes it even chance of picking. And when we get to a random number table, it keeps things even chance. So, and it just really makes it easier on our brain. Okay. So now here's the big thing. What can go wrong? What can go wrong? And when things go wrong, we call it sampling bias. So we're looking at sampling bias, and a statistical study is going to show bias if it systematically favors certain outcomes. So over and over and over, we're getting results that are not truly accurate of our population. And so that's going to be a bias. And when we're looking at bias, we're always looking at, is it going to overestimate or underestimate a certain result? Am I overestimating the number of people who want a pool at Colony High School? Or am I underestimating based on the way I sample? Now, sampling that leads to bias and systemic errors are samples that are not truly representative of the population. So that voluntary response sample and the convenience samples, they're bad. Do not do them. Because they're going to consistently give us incorrect information. And then we look like fools because we're spreading incorrect information as if it's fact when it's not. Now, please remember that most studies will require you to describe how you pick your sample so we can make sure that your information is reliable and that you have truly eliminated any bias or most bias. Always be prepared to write out how you assign your individuals numbers. Did you put them alphabetical and then number them with certain digits? Did you just randomly type up names and then assign them? How did you do that? Or did you use like already identified terms like a phone number, or did you use a student ID number? Or is that how you got those numbers? And then once you assigned the individuals numbers, how did you select those numbers? Did you use a computer? Did you use a calculator? Did you pick numbers out of a hat? Did you use a random digit table? How did you do that? And a lot of times they're going to have you explain out in words how you did it every single time. Okay. Okay, so the correct way to sample a population is through random sampling. So we talked about simple random sampling, which is the only way we've talked about so far. Tomorrow we're going to go ahead and talk about two more types of random sampling that they're specialized cases when you're worried about something in particular. Using random sampling leaves the choice of who participates to chance, and then eliminating the chance of personal bias. So any type of bias from those who are participating or running the study, anything from them is kind of taken out because everything's done by chance or randomness. And kind of going back to that systematic sample, some people will tell you that it's really a random sample as long as your numbers, like your starting value and your interval value, are randomly chosen. But there's debate about it because once a starting value is chosen, some people have no chance of being selected. So if I randomly selected number 4 as my starting, let me redo that. So if I randomly select number 4 as my starting value, the likelihood that I'm going to pick number 5 is going to be really small. And so then not everyone has an equal chance anymore because once I pick that starting value, super small chance that number 5 is going to get picked or number 3 is going to get picked. So really we're going to go ahead and stick with that system, the simple random sample or that SRS. Okay, so we're going to walk through a sample problem. The management company of a local mall plans to survey a random sample of 8 stores. So I need N to be equal to 8. That's going to be my sample size. To determine the hours they would like to stay open during the holiday season. There are 20 stores in the mall, and those are all listed below. What is the population? And so our population is, what is our entire group? What's that entire list? All the stores in the mall. All 20 stores in the mall. Now, what is our sample going to be? 8 randomly selected stores. Now, what are we measuring? So once I get my sample, what are we going to measure? Well, they want to know the hours they would like to stay open during the holiday season. So we're measuring hours the store/mall will be open during the holiday season. Okay, so what we need to do now is we need to go ahead and pick our sample. So the first thing we're going to do is we're going to have to go ahead and label our stores. So they're listed in alphabetical order there. So we're going to go ahead and label them. I can't label them with 1 digit because I have more than 10 stores. So I have to label with 2 digits. So 01, 02, 03, 04, 05, 06, 07, 08, 09, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So I've labeled my stores. So I'm going to go ahead and describe that. Label stores with 2-digit number. Now I'm going to find 2-digit numbers in my random number table. So I'm going to go ahead and I'm going to break up each line into 2-digit numbers. So here's my first line right here. I don't use this number. Now I'm going to go ahead and identify 2-digit numbers. So 19, 22, 39, 50, and I'm going to break them apart. And sometimes I find it easier just to go ahead and break apart a bunch. And then go back and find some numbers. Okay, so from here I'm going to figure out, are any of my numbers so I'm going to find 8 2-digit numbers in the list. The problem is I'm going to get some repeats, so I'm going to ignore my repeats. And I'm going to have some numbers that aren't at my list. So I'm going to ignore anything from 21 to 99, and because I started at 0, 1, I'm also going to ignore 0, 0. So I'm going to go ahead and look at it. My first number is 19. So 19 is selected. And there's my first one. And then I have 22, which is not in my list. 39, which is not in my list. 50, which is not in my list. 34, which is not in my list. And then 0, 5. So 5 is in my list. So 5 is my second business. And then what I think that's 75? Here, let me erase this really quick so I can see. Yep, 75. And then 62 and 87 and then 13. So 13 is my next one. And then 96 and then 40 and then 91 and then 20 something and then 31 and then 73 and 67 and 64 and 71 and 50. Holy cow. 99, 40, 00, 19, which I already had. 27, 27, 75, 42, 26, 48, 45, 46, 77, 17. Here's my next one. So I had 17, and then right next to it I have 09. One, two, three, four, 19, 5, 13, 17. There we go. That's where I skipped. 9. Okay, now 77, 55, 80, 00, 95, 32, 86, 32, 94, 85, 52, 71, 13, which I already had, 88, 89, 93, 7. So here's the number 7. And then 46, and then the number 2. So I'm down to 7. I need one more store. Let's see, that was number 2, and then 27, and then 40, and then 01. So the numbers were randomly put into a table using a computer. So it's a random digit table. We use those digits to help us determine our sample of 8. So our sample would consist of, and now because I circled them, I can list them in that alphabetical order. So Aeropostale, All American Burger, Carter's Famous Footwear, GameStop, Mrs. Fields, Payless, and Vitamin World. Now, ideally, we'd have a lot more room to explain what we're talking about. You want to explain so that way anyone who read your explanation would get the exact same answer. And that's why we use the random digit table in AP exams, so everyone's getting the exact same answer. Okay, so that's it for 4.1a. For 4.1b, we're going to come back and we're going to reiterate this simple random sample, and then we're going to talk about 2 more random samples that we like to use.